The class starts now.
Let's go. Actually, thermodynamics, it is focused for mainly anything related for heat, anything related for heat. So as you see here, just a simple experiment, rub your hands together, what you feel. I know you don't feel anything now because it's cold, but if you are in regular shape or regular weather, what you feel?
It's getting hot.
Yeah,
Wow.
this coming from where? This thermal energy. Okay, actually thermal energy, it is one of the important energy in the world. Everything coming from thermal. If you go back for the first thing, for primitives, you will see use it flame fire. So thermal energy, one of the top energies used, and can convert from another from shape to another. The topic for thermodynamics include many basics, many fundamentals. For example, one of the question today, I think 17, 14, something like this. In the first impression, these electrical questions, we don't, it's not including mechanical, but actually the idea for solving the total questions for this one, it's not electrical. The concept for solve this question, thermodynamics. Let's see for the first slide for thermodynamics. If you understand this clear, you can solve the question number 17 correct. Here just describe three things important. When you're going to study something, you need to define three things: boundary, system, and surrounding. What is the system? This is what you want to study. And if you want to study something, we need to make like to make a wrap for this one, to make a surrounding for this one. Okay, what is this area? This boundary. So if you want to study, for example, the room here or classroom, this is a system. So the walls, doors, windows, this is the boundaries. Anything out of this, it is surrounding. Okay, because thermodynamics, it study the relation between the system with surrounding with the system, which is define this system and this surrounding boundary. So the boundary, it is can define this system and this surrounding. Okay. Thermal energy. The meaning of thermal energy, you need thermal. So it is something related for anything hot. No, mainly it is related for kinetic energy. So the main concept for life, not for thermodynamics only. Life, kinetic energy, movement. If you have movement, we have a life. No move, no life. So thermal energy is coming from kinetic energy transient from one object to another. Due to what? Temperature difference. Please, small note, but very important. He asked between these words. Thermal energy is kinetic energy from one to another due to temperature difference. Thermal, kinetic, due to temperature difference. Three words, very important. Temperature. Why I focus for these three? Because he going for different shape for question, but end the same answer. Temperature is the average kinetic energy of particles. Temperature, it is the average kinetic energy of particles in object, not the total amount of kinetic energy. Not the total amount of kinetic energy. Not calculate total amount of kinetic energy. No, the temperature, just average kinetic energy for particles. Then for this object, I can measure the temperature for this one. For another one, we can measure the temperature for this one. If this object and another have a different temperature, so we have a thermal energy transfer from this one to another. From which one to another? From the hot side to the cold side. From hot to cold. Up to both reach to the same temperature. In this case, we can say this in thermal equilibrium. This is a third one here, thermal equilibrium. So the thermal equilibrium is obtained when touching objects within a system reach the same temperature, the thermal equilibrium. By the way, what is mechanical equilibrium? Mechanical equilibrium is related for balancing of pressure, but thermal equilibrium balancing for temperature. Okay, according to thermal equilibrium, we can see Zero's law of thermodynamics. What is Zero's law of thermodynamics? Zero's law of thermodynamics said if you have three objects, not two, but these three objects, one is in thermal equilibrium with another, and the third one is in thermal equilibrium with this one also. Okay, it means we have a one common in thermal equilibrium in two. This one is thermal equilibrium for this one, and thermal equilibrium for this one. Therefore, the begin is that the first two objects also in thermal equilibrium. So if you have two in thermal equilibrium, two in thermal equilibrium in this side and this common, so these two it is in thermal equilibrium. This is Zero's law of thermodynamics. If two systems are separately found to be in thermal equilibrium with the third system, the first two systems are in thermal equilibrium with each other. Temperature scale. We have in temperature scale Celsius and different heights. This is a regular scale, one for SI units and one for British unit. But the absolute for SI units, it's not a Celsius, it is Kelvin, and the Kelvin is equal Celsius plus 273. And in equivalent for that, also Fahrenheit. The Fahrenheit is the degree for British, but if you want to use absolute, we use Rankine, which is Rankine is equal Fahrenheit plus 459 or 460. No problem, 460. The range for Celsius from freezing to boiling is 0 to 100. The Fahrenheit from 32 to 212. So the range for Celsius is 100 degrees C. For Fahrenheit, matched or equivalent for this one is 180. Okay. We can change by calculator from Celsius to Fahrenheit to Kelvin. Three can change it together, but to Rankine, it's not in the calculator. So please save the conversion from Fahrenheit to Rankine. Be aware how to change it from Fahrenheit to Rankine, because many examples or problems coming for Fahrenheit or British, so it's coming sometimes with Fahrenheit and sometimes coming with Rankine. Okay, so let know how to change it from Fahrenheit to Rankine. Also, we're going to define the system. System we classified in three main categories. other categories is under umbrella for one of them. But the main is 3 categories. What is these categories? Open system, closed system, isolated system. And we classify these systems according to 2 parameters. Parameter related for matter or mass, and parameter related for energy. Normally energy for heat, and mass, this is other parameter. So we study these 2 parameters to define the system is isolated or closed or open. We study what? Study these 2 parameters for what? We study what is from these parameters crossing the boundary or not crossing the boundary. Can cross the boundary or no? Okay, so as you know, we have system, we have a boundary for this system, and we have a surrounding. So if we're going to study mass crossing the boundary or not, so according to that, we can classify this open or closed or isolated. Also energy, we study it is can cross the boundary or not. Let's see, for open, energy and the mass we can transfer, we can crossing the boundary, we can cross the boundary. But for closed system, we can see isolated both can't crossing, both inside the boundary, we can cross the boundary for isolated. So it's total opposite for open. But for closed is semi something between. Closed, mass can't transfer, but heat can transfer. Heat can transfer. So for open, heat and mass can transfer. For isolated, heat and mass can transfer. For closed, heat can transfer, mass can't transfer. See some questions, please. What's the answer?
All of the above.
Great.
All.
All of the above.
Okay. Let's see this gases law. Study. Boyle's law. I will tell you by easy way, don't save a lot. We have 4 laws for ideal gas: Boyle's, Charles, Gillissick, and Avogadro's hypothesis. These 4, we fix parameter and we study other parameters together. For the first 3, Boyle, Charles, and Gillissick, normally the molar mass, it is constant. But with this one, we support with another one time for temperature constant, one time for pressure constant, one time for volume constant. For Avogadro's number, pressure and temperature constant. So the relation mainly between volume and the number of moles. So by conclusion, Boyle's law, for first one, we study at temperature constant. So what is remaining? P and V. These 2, it is inversely proportional together. Inversely proportional. So we see B and V is direct proportional, inversely proportional together. So B1 V1 equal B2 V2. This is the famous equation. B1 V1 equal B2 V2. Okay. This is the first case. Charles, for the Charles, we will see pressure constant. So the relation now between, and as a default, mass also, molar mass, number of moles. So what's remaining? Temperature and volume. Temperature and volume. Both is direct proportional. Direct proportional. So V1 over V2 equal T1 over T2. Okay. What else? Same equivalent. Galactic. Galactic is the last one. Volume constant. So what's remaining? Pressure and temperature. So pressure and temperature is directly proportional. B1 over B2 equal T1 over T2. Okay. This to focus and be sure what happened for in case of Galactic, something like this here. At low temperature, the molecules are moving more slowly and will hit the wall of container less frequently, so it is with low pressure. But for temperature increase, pressure increase, so this is coming from the motion of the molecules as an increase, sticks the walls of the container more often, so the pressure increase. We can start for solve this problem, please. It's not difficult. Direct substitution. I think you can read it in 10 seconds and you can solve it in 15 seconds. I give you 1 minute total. Anyone get answer?
Increases.
Value.
Value, I need to calculate. P2 by, what did you say?
Here the volume is
I can write it the
constant,
equation for
right?
you. Which equation will be used? He talk about for the volume here.
No losses. Yes, volume is constant.
Yes, talk about for container, so volume is constant. So B1.
So P1 to P2 equal T1 to T2.
Why 17? 17 or 7? I see one is extra. For gas equation, temperature must be Kelvin. Be sure for this point, please. Temperature must be Kelvin. So here we
7 atmospheric.
6 atmospheric.
7 atmospheric is the answer.
Yes, exactly. 27 plus 273 and 77 plus 273. So we can get answer from this relation for B2, which is equal 7 atmosphere. Okay, let's see the answer here in details. This given and this answer. Here, this is like summary, Charles law, Galactic law, Boyle's law, Avogadro's hypothesis. Avogadro's hypothesis that U, B, and T is constant. So the direct relation between volume and number of moles. So V1 over V2 equal N1 over N2. This is a famous equation here. And this one
N
is
is what?
better here. This one is better there. This one is better there.
In Avogadro's hypothesis, N is what?
Again,
In Avogadro's hypothesis, what is N? V and N. N stands for what?
number of moles.
Number of moles.
This N,
Yeah.
number of moles. Okay. I think almost all gases equation is clear now. Answer?
Kelvin.
Kelvin.
The SI units for temperature is Kelvin. This is very good questions. I like it. I give you half minute to read and 1.5 minutes for solving. I like it. Anyone get answer? Let's solve together. Let's see. This learn you read, and before you start, check what is required. Okay. He gave you here B initial T initial process. We have to process from 1 to 2, process from 2 to 3. Process from 1 to 2, it's constant pressure, and they give you a relation T2 equals 3 T1 over 4. And the other process volume is constant, and they give you a relation T3 equal T1 over 2. What is the ratio of final volume? So it required final volume by initial volume. What is the refer for final volume? Last stage V3, initial volume V1. So this is the required. From first relation B, we can get a relation between temperature and the velocity and the volume. So V1 over V2 equal T1 over T2, correct? Okay. What is the value for T1 over T2? Let's see. This T2 equals 3 T1 over 4, correct? So T1 over T2.
So this initial volume of ideal gas, you said required VF by VI. What
Which
is
one?
that? How the
Required
mention
V
required is
final
VF by V1?
V final volume to initial volume.
Ah, okay. You mentioned as final and initial.
Okay. T1 by T2 can get it from here. This one up, this one down. So 4.
Sorry, Doctor, sorry for the interrupting. Now,
Again?
yeah, from 2 to 3, the process 2 to 3. T3 equal T1, right? Divided on 2. Am I correct or not?
I write here. Yes, here.
Okay. Yes. Okay. Thank you.
But this tricky condition, why he gave you this one to take you to go through in another way. Why? Because he focused for volume. From this relation in this process, it means V2 equal V3 direct. That's it. We
But
don't
we
care
have to
about
study
for this.
each process separately. Then at the end, we will make the sum for the entire volume. Correct?
Yeah, I study this one and study
With
this one.
disregard to the process.
Yeah,
Okay.
and I make a relation between these two because he need V3 by V1. So V3 by V1, it's coming from this relation. If you substitute it here, V2 equal V3 from this relation, correct? This relation tell me V equal constant. It means 2 equals 3. You are hear me or no?
3/4.
You
4 by 3.
understand me? What I mean is V2 equal V3Y?
4/3.
Because volume constant.
Because
Yeah.
volume constant for this process.
That-
So
The
substitute
2 and 3 is constant volume, so the V2 is the V3 also.
yes. So V1 I put it the same. Divide V2 I can put it V3. So V1 over V3 equal 4/3. But the required is 3/1. 3/1 because final over initial. So this is the same this one, but just I need to reciprocal for this one. Use reciprocal for this one, which is equal to 3/4. So what is the exact answer?
0.75.
0.75.
Exact answer is C. Please, if you have any question for this problem, tell me. Any question? No?
No.
Let's go to next. What is the unit of mass?
kg, kilogram,
Kilogram.
Yes. Quickly. What is the unit of time?
second,
Second.
Second.
What is the unit of length?
meter,
Meter.
What's the unit of energy?
Joule.
Joule.
According to Gilasic, for perfect absolute pressure of given mass varies directly as
volume if temperature is kept constant.
excellent.
Oh, sorry, absolute temperature if volume is kept
Absolute
constant.
temperature if volume is kept constant. This is what you said, correct or no?
Yeah.
Absolute temperature if volume kept constant. Ideal gas are compared to real gas at very high pressure occupies
Same volume.
Yeah, less
Less
volume.
volume.
Less volume.
because for real gas it's going to extend. So it's going to take more volume due to expansion. General gas equation is
Excuse
K
me,
equal to nRT.
excuse me, sir. The number 9 question.
nRT.
okay. I will go back, but for this one,
nRT.
A or B?
A,
B.
A. Number of
Molecule.
moles.
number of
Yes,
molecules and
number of moles. Okay, sir. What's questions?
The number it occupies. Is it more volume, but the answer flashes less volume?
Ideal gas, it is take less volume.
Yeah.
The real gas, it is take more volume because it's going to expand due to expansion for the flow work and something like this. You see here?
Yeah, the question is ideal gas, so less volume.
Yeah. He mainly related for ideal.
Yes.
Okay,
yes.
ideal
Correct.
compared to real, not opposite. You know Dalton's law? Easy law, very excellent law. Dalton's law talk about for pressure of mixture. What's the pressure for mixture? Pressure for mixture, it is equal sum of all partial pressure for this component. Like if you have a mixture including for this one hydrogen and nitrogen and oxygen, so the partial pressure for this one, the pressure for this one separate, and the pressure for this one separate, and the partial pressure for this one separate. If you make plus plus plus, you will get the total pressure for the mixture. For example, some experiment in lab, we need to fill a device this device is coming from mixing between gases. So he give you setup, for example, this type it is up to 200 bar, and this other one up to 500 bar, and this other one up to 2000 bar or 2000 or 1000 bar, for example. No, it's not make sense. That's very high. 100 bar. Okay, so I will put the first one, fill the first one up to reach to the pressure gauge reading, the first partial pressure for first one. Then release this one. Put the next one. Continue filling up to reach to the setting required. Bring the third one and connect up to reach to the maximum required. So what you see now is the final pressure required. So from where is this final pressure required? It's coming from the sum of partial pressure for each one. Okay, Dalton's law. For example, here you have nitrogen 4.48 partial pressure, and we have oxygen the same 4.48 partial pressure. So what is the pressure for the gas, including these two types of the gases, nitrogen and oxygen? It's equal to 4.48 atmospheric plus 4.48 atmospheric. The conclusion, it is the final pressure for this mixture. Clear Dalton's law? Dalton's law is okay?
Okay.
Clear.
Clear.
According to Dalton's law, the total pressure of a mixture of gases is equal to
Three.
C.
Sum of
Sum of
C.
partial
Sum of partial
partial
pressure of all. C.
Which of the following can be regarded as gas so that gas laws could be applicable within a commonly encountered temperature?
D.
D or B?
D. Oxygen, nitrogen, hydrogen, and air.
Yes, D. Correct. Ideal gas with constant value of specific heat for calculation of the specific enthalpy.
Only temperature. A.
Only temperature. Exactly. What is the unit of the pressure?
Pascal.
Pascal.
A. Or Pascal.
Pascal for SI, correct.
Kilogram. Pascal.
Closed system, which one?
Mass,
A.
neither
A.
mass nor
A.
energy. C or C.
A. C is for isolated system.
If this one or neither this and this, isolated, exactly. So the answer, mass doesn't cross, energy can cross. Temperature of a gas is produced due to
Kinetic energy. B.
Kinetic energy of molecules.
yeah. According to kinetic theory of gas, the absolute zero temperature is attended one.
All kinetic is moved.
C.
Kinetic
Kinetic
energy of
energy.
the molecule is zero.
Yes, exactly. Okay. What is difference between elastic and inelastic bodies? If you have two bodies, these two bodies is moving, or maybe one it's not moved, and the other one is moved. What happened due to collisions? We have two ways. Elastic collision, so everything not a change. It means kinetic energy conserved and momentum is conserved. Okay, so the kinetic energy before collision is the same after collision. So this elastic. This example, so like ball of billiards. But inelastic, it means the kinetic energy after collision, it changed with the kinetic energy before collisions. So it is different between before and after. This inelastic collisions. Due to what? Due to many things like car make accident, so we can make losing for the energy and going transfer to another way, like for deformation for the car, like heats going up, coming and released from the car, whatever. But the energy at the end, it's not the same. So kinetic energy changed, but momentum still the same conservative. So here some notes like perfectly elastic collision is defined as one on which there is no losses of kinetic energy in the collision. Inelastic collision is one in which part of the kinetic energy is changed to some other form of energy. Primary difference between elastic and inelastic is inelastic collision kinetic energy conserved, but inelastic collision kinetic energy is not conserved. But both elastic and inelastic collisions momentum is conserved. Okay. This example, I tell you this example for the car accident, for example. This some cases for what happened before and after. For example, if you are going to check the first case here, before collision, we have a mass moved with velocity v and other mass is stationary. What happened? This is expected to happen. After collision, the first one it's going to be stopped and the other one it will be moved. Before collision here, for these two body view, this one coming in the right side, this left side, both it's moved. After collision, both is going to the opposite side. Okay. Still the mass not changed. Only change is velocity. Here before collisions, both going in the same way. But after collision, if this one it's moved with higher velocity than this one, so after collision we will see both, for example, it's moved in the same way but with different velocity due to the collision happened between this body and this body. It's moved this one with different than the other or the previous velocity. One of the case also, if this moved and this station is same like this body, first case, but another option happen, not this happen. It's more one stop and the other one move. No, it will go to combine together and moved as one body, moved as one body. So in this case, we can say this one, it is perfectly inelastic. So it's slightly difficult name, perfectly inelastic. Okay. The equation used for this topic for energy collisions here, M1v1 plus M2 v2 equal M1 v1 dash plus M2 v2 dash. This is a famous equation used here. Okay, so we have masses the same, not a change, but the change is the velocities. Change is the velocities. Okay, for the last case here, for example, this one, in the first case, the mass 2 it is not moving, so this one is 0, so this cancel from the side, and the right side it will go the first mass and the second mass with the same velocity is moved. So mass 1 plus mass 2 it is moved with v1 dash. There's a equation here coming. Okay, so don't solve more question just to save the idea questions. Okay. Okay, let's see some problem for this part. What's example for perfectly elastic collision? Perfectly elastic, not perfectly inelastic. Perfectly elastic, same like the two billiards balls can be regarded as perfectly elastic collisions. Kinetic theory of gases assumes that collisions between the molecules are
Perfectly elastic. A.
exactly perfectly elastic. Some problem for that. I give you one note to can solve this problem without any mistake. What is the trick for this problem? The velocity should be substituted as a vector, not scalar only. It means the direction for the velocity is very important in the equation. So here we have two masses, mass 1000 kilogram and 1500 kilogram. After collision, the same mass not a change. But this velocity 2 meters per second right, this 5 meters per second left. After collision, this is still left with 1 meter per second only, but we need the other velocity. Actually, these values is related for each object. So this one, it will be V1, V2. So this one, it will be V1 dash, V2 dash. So when going to substitution, first put yourself positive direction. So this one, 1000 kilogram, multiply 2 meters per second, 2 meters per second in this right direction, which is positive for me. So I put it 2 meters per second positive. But other term is 1500, multiply 5, which is the velocity, but in opposite direction, so it will be negative, opposite here. This is opposite. So negative 5. After collision, this is before collision first. M1, V1, M2, V2. But be careful for sign, be careful for directions.
Units.
Units for units. Yes, excellent. Other side, the mass is the same. Mass 1 is the same, not a change. Mass 2, not a change. But what it will be change the velocity. So this B dash at the same. I put it the same. And the other one is 1 meter left. So left here, as I put it here, this direction for me is right positive. So left is negative. So I write it negative 1 meter per second. If we're going to just simple calculation, this multiplies this multiplies this one, equal this one plus this one. This also decided the value, so we can put it on another side. We can this part term plus this term minus this term, you get 1000 v dash. Divided the value by 1000, you can get what? You can get the velocity direct. Here, same like this. 2 stage. Just focus during substitution. That's it. Another problem here. Take time for solving. I gave you 2 minutes for solving. I think it not take more than 2 minutes. Anyone get answer? Answer, please. No one get answer? Let's see the answer together. You mentioned here elastic collisions. 2.5 kilogram steel ball is traveling east. So the direction here is east and west. So put the east and west. East. Sorry. West. So I put this positive direction for me. So east positive. So that is the equation. M1 V1 plus M2 V2 equal M1 V1 dash plus M2 V2 dash. Let's go to substitution. What's M1?
0.25.
Why? Something is not. Let's see. 0.25. Velocity 1.
4.5.
4.5.
East or west?
East.
So it's positive.
Positive.
Yes. M2. 0.3. V2.
-5.
Yes, 5, and both negative because it's west. Equal M1, not a change. Even it's gave you or not a change. V1 dash is required, correct? No. V1
No.
dash 2 meters per second, correct? Which is given here.
Yes. After the collision, it's traveling west 2 meter per second.
Yeah, the
After collision, yani. So this is V2.
-2 because west, correct?
traveling west, yes, -2.
V2 dash.
V2 dash.
So the required is V2 dash. One equation, one step, you can get the V2. Very easy problem. Sign is the trick for this problem. Only that.
The
Okay.
answer is 0.417.
Answer is just a minute. Yes, okay, but I think we have sign, it's not correct. This sign is not correct. When delete this sign. You get 4.417?
Yes, yes.
Yes, it's okay. And positive, it means it is in the east direction, correct?
Yeah.
The pressure of a gas in terms of its mean kinetic energy per unit volume. Any idea?
No.
No idea?
T.
E. Let's see.
C.
C, I
Actually,
think.
here you need a required relation between energy and the pressure. Okay. Actually, we have a relation between the average energy, average kinetic energy, or mean kinetic energy, and temperature. This we have. Okay, this is coming from where? From the kinetic theory relation. Let's see this. See this kinetic theory relation. We have here kinetic energy average, a relation between this one, average kinetic energy, and temperature. Okay, we have two relation, one like this and one like this, one function for temperature and the other also function for temperature, but one per molecule and one per mole. Okay, so let's see this relation here. Average kinetic energy or mean kinetic energy, it is equal to 3/2 or 2/3. 3/2 or universal temperature. There's a relation between this one and temperature, but he don't need temperature. He need what? And he mentioned per mole. What is per mole? This one per mole. This one per mole. Okay, it means this one multiply number of moles. Okay, so this is the relation we have from theory, but here he need a pressure.
Sorry,
we
Dr.
know
Here, where's the
under
mention
pressure
regarding the mole?
again.
Not
Question. Okay.
How do we know it is per mole or per molecule?
Why you don't use another one?
There are two equations, right? One for per molecule.
Yeah, both the same, but one for per molecular, it is function from KT, not RT. This it's Boltzmann constant. Okay, this per molecular. So this molecule with Boltzmann constant, we can get a relation in R bar and number of moles. This kinetic theory, Avogadro's number theory. Here, you see where this here. This Boltzmann constant. Okay, but this universal gas constant. So if you use Boltzmann constant, okay, you use per molecule. If you use universal gas constant, you will use per mole, not per molecule. So I will use this one for N is better. Why? Because the required here, he needs this average as a function of pressure. So the nearest thing to pressure, which one? R and T. Why? In the ideal gas equation. If you see the ideal gas equation, just a minute.
Will be equal to nRT.
Yes, exactly. BV equal nRT. So this nRT actually. So we can put this instead of that. So E average equals 3/2 BV. Okay, what he needs to pressure as a function for E. So the pressure is equal 2/3 E average per volume. Correct? Yes. Actually, what he needs mean average kinetic energy per unit volume. So it's consider volume as 1. Consider volume as a 1. So the final is B is equal to 2/3 average kinetic energy. 2/3 average kinetic energy. This one. Okay. Open system, which one is correct answer?
C. Both energy and mass can
Option
cross
C,
over.
sir.
Yes. Excellent. What's meaning of superheated vapor behavior?
As a steam.
as a steam.
Approximately as a gas. We'll see in the problem for when we're going to study power cycles, we'll study Rankine cycle and gas cycles and so on. For gas cycles, all cycles, you can calculate work or heat by using something called enthalpy. Enthalpy, it is referred to the total energy, H, this enthalpy. We see also one here problem, need to calculate H. H is equal to U plus BV. U is internal energy, BV, it is the flow energy. This is enthalpy or total energy or potential energy, have the same name, okay? Enthalpy. It's okay, this one. This enthalpy, it is the main thing for calculation of energy for anything. So if you need to calculate anything related for cycles or equipment like compressor, evaporator, condenser, turbine, pump, anything, to going to calculate heat, boiler, whatever, heat or work for this equipment, the main idea for anyone is difference between two enthalpies. So you need enthalpy before, enthalpy after. It means energy before, energy after, minus difference. You can get work or heat according to the type of this equipment. Is give heat or give work. Okay, or you need heat or you need work. Clear? So one of the important is enthalpy. Enthalpy for steams or water, it's coming from tables and charts. But in Syllabus for gases, we have a equation direct. We can calculate this one because in Syllabus for gases, in Syllabus we have one question here. In Syllabus, it is a function direct for temperature. In Enthalpy is a function for direct for temperature. So if you know the temperature for initial, temperature for final, you can get enthalpy in, enthalpy out. This were in gases. But if the problem talk about for steam, we have H. We have one problem in coming in the exam in UPDA. This problem, it is steam, but the question shared in the material internet, it is superheated, steam superheated range, and it's not given H and required something related for H, required efficiency, required work, required something like this for equipment, but it's not given anything related from tables or chart, because the steam, it is water, it's from tables. It's given temperature and pressure. So the only way to solve this one, we can use it superheated vapor behavior approximately as a gas, and we can use, in this case, it's not exactly correct, but this is the only way to solve. We consider this one to calculate it as a gas by using the temperature given and using the equation for the enthalpy function for temperature, not from tables or charts. Clear? I discussed this case because I found question here superheated vapor behavior, so I consider approximately as a gas. So I remember the question related for this. I tell you. Okay.
Sorry, doctor.
Yes.
Yeah. Can we step one step back? What is the difference between answer E and D?
Please
The
repeat
question. Can we go one step back?
One step back. Okay. More?
Not the answer, actually. Yeah. Yeah. Here, what is the difference between D and D?
What's the difference
This,
between what?
like approximately as a gas. So here we can consider also it is average between gas and vapor, right?
Approximately, because it is not a gas.
D and E, there is a difference.
As average of gas and vapor? No, we consider as approximately as a gas because superheated, it means it's totally steam and I increase the temperature more, so it is likely gas. But not exactly gas. Last one, it is.
But it is a gas only, no, sir?
It is?
It is gas, no, when we superheat it. So it becomes gas.
No,
So
but
exactly or approximately how this
approximately, because it is not a gas. It is still water coming from water. It's not, this is coming from steam. Like heated steam. So it is still not a gas pure.
Yes, because in the steam there's a
it is like
X, there's a moisture.
example when we boil water, it start boiling at 100 degree and then at constant pressure
No.
changes to
Yeah, the behavior is like this.
wet steam, then dry steam,
This behavior.
then superheated steam.
This is a profile for water.
Yeah.
So the H line from this like this, this constant pressure line, constant pressure line. Okay, it means at certain pressure. Okay, so
Yes.
at certain pressure in this range, the phase is totally liquid up to reach to this line.
Yes.
Intersect this saturated line.
Saturated line.
Yes, this saturated liquid, this saturated steam.
Saturated
So here
region.
it start to boil at this temperature.
Yes.
If this atmospheric pressure, so this temperature is 100. Okay, if this not this not atmospheric pressure, this temperature, it is change. But by the way, here is start to boil. at what, at 100, for example, but 100 at pressure.
100.
So this range is going from liquid phase
Wet
starting
to liquid, like wet steam to dry steam.
gas here in between. So this part for change phase, latent heat. Okay. After reach to
Okay.
this one, now is totally steam. You increase or add
Dry steam.
dry steam, yes. This wet steam here.
Yeah.
So if you add energy more, now latent heat finish, phase change finish. What happened? Temperature increase again. So we have
Superheat.
yes, this superheated, whatever the temperature required, superheated. Okay.
So he's asking the dry point or the starting point of superheat.
No. He talk about for here superheated vapor. It means this range.
That's right.
Okay.
So it is approximately gas,
Approximately
as we understand. Oh.
Absolute zero pressure will occur when
Under vacuum conditions.
D.
D.
under vacuum conditions. But
C.
the question is direct, zero pressure. It's not about for
Oh, C. When molecular momentum of system becomes zero.
okay. Exactly. No liquid can exist as liquid at
Zero pressure.
Vacuum.
zero pressure, nothing.
Liquid can exist.
What is the unit of power?
What?
Watt.
What? Condition of perfect vacuum.
Minus 273.
Minus 273.
Yeah,
Okay.
this is a tricky question because negative 273, 1, 273, and 0, negative 273. Intensive property
Is
means
negative 273 also same the absolute pressure also, no?
yes, absolute zero pressure. Yes.
Yeah.
0 Kelvin at absolute zero pressure. What's intensive property?
Does not depend on mass. B.
Does not
Depends.
depend on mass.
Just
Okay, I give you 5-minute break. It's not remaining a lot. I think this question and one question more. Just relax because this one
So
need to be relaxed and refresh. Just 5 minutes and go
better
back.
we finish and then go, sir. Colors.
Okay.
Is it if you have two questions, we will finish and then
Yeah,
next class we
but we
continue.
have exam. We solve it
Better,
together.
I think.
Read to solve. Actually, this question, it's not coming like this in exam totally, but each part for this two coming in the exam. It means I give you here two formula, this one and this one. This one coming a lot in the exam alone, separate, and this also coming separate alone. Okay.
Sir, before you said PV is equal to NRT, here MRT.
Yeah. You have two equations for ideal gas. PV equal nRT. This is a general one, and we have another one, PV equal
MRT.
But the difference is what this R is universal gas constant. Universal gas constant, it means 1 R for all gases, one value for all. It's applied for all gases. So this is used as a general. But for this case, this R, it is specific for each gas. It means for air, we have R like this. This R for air. which is this is the type of the gas here. Okay, so this information for air, for example, this air information, R for air, CV for air, all this, whatever this or this. Okay, but this R is general. Clear?
So if you not
Like,
mention in the question it mentioned gas. So we consider PV is equal to nRT if it says any type of gas like air or
No, according to
nitrogen or anything.
no, according to the required for the problem. For example, here in this problem, we need to calculate mass because the required is Q and mass not given, and we have some information
Okay.
for B, V, and T. So the better way we can use a B, V, and T by this formula to get what? To get mass. Do you understand me?
yeah, in that PV equal to
But-
nRT, N means number of
I
molecules.
use this one as a supported equation to get mass, which is the required actually here, to get Q. So according to the problem, I use the equation BV equal nRT or BV equal MRT. But what you I need from you to be clear for you. M so R here for specific gas. N number
Yes,
of
sir. Now here he
R
give
for one value for all gases.
here in this
Here what?
if in this question if R is not given, then we take the equation of PV nRT. But
No.
since he give the R value,
No. Even R not given, still N is not required here in this problem. The required is M. Okay.
Clear.
In nRT, N means what, sir? Number of molecules?
Number of N is number of molecules. M is mass.
Okay.
Sorry, N is number of moles.
Okay.
N number of moles. Okay, finish reading.
Yes.
Let's start. Focus with me, please. I put here many tricks in this problem. Many tricks. First, I give you two states. Let's see these two states. State 1, state 2. For state 1, I give you pressure 1 bar. And they give you temperature 15
degree.
Next day is Celsius temperature
5 degree.
5 Celsius degree. Volume 2500
2500
centimeter cube. The required heat lost, which is Q, and B2 gauge. Okay. Also, this one is gauge. He gives you this one gauge. Okay, let's see. First, B2 gauge. This is easy one. He give you volume constant. So I use this rule, volume constant. So B1 over B2, or I can start by B2. Yes, B1 2 by B1 is better. Equal
T2 by T1
by T1. Okay. Why I make it resist change? It's better because I put this other side and they can calculate B2 direct. We don't need to make rotation reciprocal again. One. So it's better 2 over 1, 2 over 1. Both the same. 2 over 1, 2 over 1, 1 over 2, 1 over 2. Both the same. So it's better like this. But what is the first trick? Celsius must be Kelvin. So this one plus
273
273 and this plus 273. So get the answer here. 278 Kelvin.
Pressure we convert also bar to
Kelvin.
Yeah, gauge pressure to absolute.
Second trick. This must be absolute. But bar okay? Yes, no problem. Why? because this ratio bar and bar, but I can't use it here. For example, BV equal MRT, I can't use it bar because B with a different unit with different unit should be all is equivalent. But here, okay, because this one and this one is ratio. You understand me? So this one should be changed to absolute. This is the only trick. Be absolute equal 1
In
bar.
that P2 by
1
P1,
plus
P1,
1,
T2 by T1 in that
1.013.
formula, T in Kelvin, P in absolute, right, sir?
Is this absolute here? Pressure
Temperature,
is absolute.
pressure in absolute, temperature in Kelvin.
Kelvin.
All.
Yes. So
Volume?
1 bar, I will add for 1 bar 1.013 bar. This what? This is atmospheric, correct?
Yes.
So we obtain
Yes.
2.13 bar. Now is what? Absolute. So I write it here, B2, B1, which is 2.013.
Is equal to P2 is 1.94 bars. Absolute answer.
Again,
Direct T2 by T1 into P1. The value coming 1.94.
19,
Yeah, 1.94.
like this.
Yes.
Sure? Or the answer?
Yeah, P2.
B2 at the end.
The direct answer. Yeah.
Yeah.
Yes.
So this B2 by this one equal T2 is
278 by 288.
So I just take it here. B2, it will be this divided by this multiply 2 blah blah blah. It will get
1.94
4 bar
bar.
absolute.
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 What is required?
Absolute.
Gauge. So we need to make minus again, correct?
Yeah.
Be careful because this
Yes.
one it is including in the choices. So the correct is not this one. The correct is minus again 1.013 to obtain gauge B2 gauge equal 0.992 bar. Exactly. Clear now?
Clear.
Okay. That's first required. Second required, you need Q lost, which is this one. So let's start. Q lost equal M CV delta T. Delta T we have. Delta T use it Kelvin's lasers.
T1 we have.
Use
Yeah.
this difference. CV is given. Remaining is mass. So we need to calculate mass first. Let's calculate mass first. Mass. From where? From this equation. BV equal M.
PV is equal to MRT.
So M is equal B
PB over RT.
over RT.
RT.
Let's substitute B. B where whatever B1 or B2 as you wish. But if you use B1, use T1. If you use B2, use T2. So B1 is absolute 2.013. This bar, we can continue by bar? No. Should be changed to
Pascal.
Pascal, 10 to the power 5.
Minor.
Multiply. Volume.
In kilopascal for say.
Why can't we same use value of absolute?
Is this absolute?
Okay.
Same like this? Same like this pressure here, absolute. But this
Bar
bar
to Pascal. We have to convert bar to Pascal.
accepted here should be all equivalent units, standard units. Here I continue by bar because I get this ratio, bar and bar. But here no, this different units. So all should be matched with the standard. Okay. So B Pascal. So the unit is the value is 2.1013 bar. Multiply 10 to
In the equation you mean to say, sir, PV equal to MRT. So the in that equation P is always in Pascal.
Yes, this Pascal, this meter cube, to obtain this per kilogram, this joule, kilogram, Kelvin, this Kelvin. Okay.
Okay, clear, sir. Clear.
Volume
Thank you.
2500 centimeter cube. So 2500 multiply 10 to power
10 to
negative
power minus 6. Yeah.
-2 for centimeter to meter, and this cube, which is -2, -2, -2, it means -6. R, this given 287. 287. What's remaining? Temperature is 15 minus 5, or 278 minus 288, whatever. No, sorry. This is only
No,
T.
no, only 288.
So this T is 15. Just a minute. Wait, close. Wait, my laptop. I'll give you alarm with this. I hate it. Wait. Let's continue.
Only 288.
Just a minute.
215.
Temperature.
288.
I used
Kelvin, no?
T1, so I use T1, 288. 288. So get mass value by kilogram. Once you get mass, you can substitute here for Q. Mass, I will put it here. CV, it's here, 0.718. But be careful, this 718 kilojoule per kilogram Kelvin. What I mean that it will get Q direct by kilojoule. Okay. If you substitute by kilojoule, you get by kilojoule. Okay. If you want to get it by joule, so substitute this one, 718. You understand me? Multiply what? Multiply delta T. Delta T is 10. Mass, don't write all this in the equation, in the calculator, because we have 10 to power 5, correct? And we have 10 to power -6. So we can cancel together. Don't put everything on the calculator. What I mean, this 10 to power 5 with 0, it means 10 to power 6. So it cancels with 10 to power -6. Easier for calculation, correct?
Okay.
So the mass.
So 2.013
the mass is
into 250
multiply
287
287 divided to 88
0.006.
6.
is 0.006.
6.
Whatever. What I don't lose your calculation from the calculator. Once you get this value, continue calculation. It means keep it on the calculator and times 0.718 times 10, get the answer direct, which is
This value is correct. 6.088 10 to the power -3.
yes. This is the final answer for Q, but kilojoule. The answer here, when I press now, you will see this in joules. So multiply 1000 to get it by joule. So it equal 43.7 joule. Okay.
Excuse me, doctor.
Yes.
The 2.03 absolute pressure.
Where?
Time. Yeah, that one. 2.03 times 10 to the power 5.
Yeah.
Yeah, we convert that to Pascal, right?
Yes.
So
This
Pascal
part.
to kilopascal is times 10 to 3, right?
From bar to kilopascal, 10 to power 2. From bar to Pascal, direct
Yeah,
10 to power 2. I need 2 Pascal, not kilopascal.
Pascal. Yes, yes. Okay, okay. Yes,
Okay.
because 100. Yeah.
Kilo, it is not standard. Standard without kilo. Any question?
This the one calculation what 2.013 into 250 I make divide by 287 into 288.
Just I write press
This 6
2.013 times 250 divide 287 divide 2.
yeah. What I'm getting is 6.088 10 to the power minus 3. So you get 0.006. It's the same value?
I think so.
Yeah, it's the same value. It's the same value.
But just press continue. Don't keep like this. Continue. We don't need mass. I need the final. Just continue. Multiply 0.718. Multiply 10 and get the answer. Continue calculation. This one, it will be added here to continue, correct?
Yeah.
Yeah.
Continue. This is what I do in the exam. If I continue like this, I need mass. I can make side calculation here to take this, put it here. So sometimes I just this, it means x, and I put here x because x in my calculator, still in the PC calculator. I will just put and continue on the calculation itself.
Okay, correct. So
Make,
it's coming the same value,
calculation and start
0.0437.
from scratch. No. You stop here, continue calculation. Okay.
Okay.
Actually, this problem, I describe 3 types of problem in the exam. This one, this one, this 2, this 3. Okay.
Okay. But in exams like this question, it will take time. How
No,
the
not
people will
coming.
finish within 3 minutes?
No, not all coming. One of the 3.
One of the 3.
I gave you 3 different idea coming in the exam. Okay.
Okay, clear. Answer is 43. Is the last?
I think so. Easy problem, but have still trick in the units. No idea?
No idea, sir. Forget all.
It's easy. Direct substitution.
Yes,
You-
3138.
This
Answer
you direct. Answer is what?
A.
I think. B here. V here. Only units. Only we need from you make balance for units. That's it. U is 2864 kilojoule per kilogram. What is H required unit? Kilojoule per kilogram. Still this match it, okay? Plus B 8, but this megapascal, so it's not matching.
Into 10 power 3.
This is the trick for this problem. 10 to the power 3 multiply V, which is 0.03432. This together. That's it. Anyone
So
going to
this
multiply,
megapascal we convert to pascals, right?
if you want to calculate
10
this
to the power 3.
10 to the power 6 to be Pascal. No, now I just multiply 10 to the power 3 to be kilopascal. If you multiply 10 to the power 6, now it is Pascal. But in this case, In this case, this must be multiplied 10 to power 3 to be joule per kilogram, because I can't match between Pascal with kilojoule. You have to option kilojoule with kilopascal or joule with Pascal. This is the drop for many engineers. Very simple problem coming in the exam, but as you see, unit. Now unit is clear.
Clear.
You know difference between these two?
Yeah, this is for Pascal.
This all
And joule. Yes.
kilojoule and kilopascal.
Kilo. Yes.
Yeah.
Kilojoule.
Pascal and joule indicated joule.
Joule per kg. The other will give answer in joule per kg. Yeah.
Clear?
But mass will V will change, sir. Cubic. If we put Pascal in unit pressure Pascal, so what will be the volume of
No,
V,
volume is the same.
unit
Meter
of V?
kilogram is standard, not a change.
Standard? Okay.
Yes,
Okay.
meter cube,
Clear.
kilogram.
Pascal means joule per meter cube, right?
Answer required kilojoule per kilogram. So if you calculate by the second step, this one, if you calculate it by this one, you will get answer more than zeros here. Like, for example, if the correct answer is 3138, you will see like this 31385 or 560. Why?
30, yeah. 3 point will be added.
Because you want to put the digit after 3 point like this. Sorry.
Correct.
You want to put point here. For example, if you wanted to change it from kilojoule to joule. You understand? So if you calculate it by this way, you obtain it like this with joule per kilogram. So we need to convert it again to be kilojoule with kilogram. But if you calculate it with first step, you obtain the answer direct. But be careful. Use it kilojoule. This one change it from megapascal to kilojoule only, not for joule. Or sorry, not for Pascal. Okay, to kilopascal, not Pascal. This problem not take time from you. I think it's take 20 seconds, 30 seconds, but you can lose it like this. Okay?
Units.
Units.
Joule equal Pascal equal to joule per meter cube, sir. Right?
Pascal is what?
Joule per meter cube. Yes, Pascal is.
No,
Joule per kg.
Per meter square. Because pressure is force over area, so it is Newton per meter square. Okay?
Yeah, pressure and specific volume will get joule per kilogram.
Pressure and specific volume, you get work.
Yeah.
And this is specific because the volume is specific, and also the internal energy is specific. Yes, specific, it means per kilogram.
Newton meter per kilogram. So joule per kilogram. Yeah, exactly.
Clear?
Yeah.
Answer 3138, which is 8. Yes, correct number. Excellent.
The Newton meter is joule. Newton meter.
Yes.
Yes.
Newton meter joule, yes. Newton meter joule.
Okay.
Just to go to back for the equation, work is equal force times distance. Okay. Thank you so much. I think simple today, yes?
Yes, very simple. We have good dreams today.
Yeah, this is good for you. Because the last one, I know it is very hard for
The
information.
pumps.
Yes, it's huge.
Previous topic.
But be ready for coming. Just to make refreshment in the middle. Going to the exam. I just opened the exam. Just a minute. Easy exam also. First question.
C.
Mm,
So can you share the screen so that?
yes. First minute. Now it's okay. C is correct. Yes. Excellent. Next.
D.
D. D. Yes. D. Next.
B.
B.
B, fire damper.
Yes. 4.
B also.
B also semi-annually. 5.
A.
5C.
C 460.
Fahrenheit scale absolute 0. Fahrenheit not Celsius. So 0 is related for Rankine. 460.
Absolute 0.
Absolute 0 for Rankine because this is Fahrenheit,
Fahrenheit is asking. Is Fahrenheit.
not Celsius.
Fahrenheit is minus 460.
6.
This question 6 is
All the above.
All the above. Yes.
no, not all. Not all, sir. The claiming insurance is like a process.
Yeah, it's not time bound.
Brother.
It's a project. Yes.
It is a project.
Yes.
No, claiming insurance, it doesn't have definite start and end. No.
Okay. Take snapshot. Send on WhatsApp. Check with Mr. Ravi. No problem.
I think answer is C.
I open mine. No problem. I also just share it. No problem.
Yeah, there's a document to pursue. So claiming of insurance is a project.
1 minute.
To claim the insurance, you have to project that.
Yes.
Okay. Evaporator option 7A.
I just send the message for WhatsApp. Mr. Ravi. Mr. Ravi, please, is number 6. Just give me check for number 6 is the answer. Correct answer. Which one? No problem. I give you the answer now. Number 7.
7A. A.
7A.
8A.
A. Yes. 8. A. Correct. 9.
9 also.
A.
3 A's.
No?
No, I talk about for 7, 8, 9. This 3. See?
Yeah, 3A.
3A.
Which one? Not number 3.
What is the answer of 9?
9 A's.
A. Na? Okay.
Yes, true.
Doctor, it is strange but true.
Which one?
The 3A answer in order. A.
Yeah.
From 7 to 9.
7 to 9, yes. Inshallah, all get A. 10.
10A.
No.
B.
A.
You select this or this. No, 10 we will solve it together, no problem. 11.
D.
B.
Function of cooling tower in
11
Condensary.
the condenser.
C.
Yes. 12.
Excuse
What is
me,
the answer
doctor.
of 11?
11,
What is
sir?
the answer of 11?
C.
11C.
11C, yeah, correct. Condenser.
Yes.
Is an instrument used to measure relative
12.
psychometer.
12A.
A. 13.
D.
D. 14.
A.
Excellent.
Thank you.
Without solving. With
No, no,
solving.
I solved it.
We
I
14
solved it.
clearly.
Sir, sir, 14
solved
is
it, but I-
178.
Yeah, yes, 178. This is the required in the question in the presentation. When I request H bump, here I change something in the equation.
And
Oh,
also.
okay.
I only request the losses. So the difference between 620 and 520 is not required. I just focus for losses. So the losses alone is 78.
Okay.
Actually, I
Take part for asking same questions, but just take part. Okay.
Okay. Okay.
I
Because
got
you
the
know,
answer as 76.45.
and the answers, and give you the same question with the values. Make trick like this. Okay.
I got the answer as 76.45, not 78 exactly.
Yeah, 78.
I-
Because he focused for major losses only. 15.
A.
A. 16.
Not
D.
sure, but
A.
A.
What?
A.
No, we are talking about 15 now or
16.
16. 16.
16 D, right, doctor? D.
15 A. 16
A.
A.
A also. 17. Before you give me answer, remember what we said in the first slide today in thermodynamics.
Yeah, C, doctor, C.
C.
17,
Inside the border C. C.
yes, 17 electrical signal input,
Yes.
because this what it is crossing the boundary. Because we talk about for boundary, not total system, from speaker to speaker. No, boundary. What
only
is
inside
into the
the
boundary,
boundary.
what is out from the boundary. So electrical signal input and out is sound. This clear for all?
Oh, okay. Okay. So,
Thermodynamics.
excuse me,
Thermodynamics. If
doctor.
I give this question for electrical division, electrical discipline, it's solved wrong, by the way, because the idea for thermodynamics is not there.
For electrical, it's the sound signal.
Amplifier, inside the border.
Yeah.
You should look inside the border only. Whatever is disregard what is outside.
Yes, you talk about for boundary. Yes.
Yeah.
This boundary. This boundary.
What the answer here? C?
See, this
C.
electric here.
C.
This electric cross the boundary. This is the input here.
C يعني.
This C, yes.
I will see.
And output speaker. So the answer is C. 18.
18C.
5 numbers. Go back for number 10. Number 10 is easy.
This time only 18 question, doctor, not 25.
Yeah. I will provide you for more questions. Don't worry.
Today discount as time is lacking.
Yeah, this the
Yeah.
reason I finished early today.
Excuse me, doctor. The number 16 question and the thermodynamics.
16 or 17?
16.
16 is A.
Ah, okay. Okay.
Okay.
Number 2, Doctor.
2.
Question number 2.
D.
D.
Yes.
Okay.
Here he need minor losses. This is the equation given. Give the equation totally. H losses equal V square over 2G 2K 90 plus K 45. Where is velocity? It's not given velocity, but we have Q, this value or this value, whatever.
QAV.
Q is equal heavy face AV. So velocity is equal Q over A, so equal this point 185. But be careful, this meter cube per minute. So we need to change it to second.
Per second.
Minute
By 60.
second.
Divided by 60.
1 minute 60. So divided by 60. Area is pi over 4 d square. Where is d?
19.
0.019 square. So get it velocity. I remember velocity is around 10 something.
9.38.
Sir, but they mentioned V is equal to V by A. relation
Which one?
in the question. Useful relation V is equal to V by A.
Which one? This one?
Yeah.
Yes, this one is equivalent for this one. V is equal V over A. Here V is referred to Q.
Okay.
So we need to be remember the equations, okay? So if you change it symbol like this, I know this V is referred to Q. I know this equation. You understand me? Because he used other symbols, but you know idea. This V is velocity, this V is Q, and so on.
Okay.
But this as per given in the exam.
But that means it is really confusing, no, sir?
Yeah.
How do we know in his mind he consider V is
And you start and you don't aware for the equations and something like this, you lose the problem. You don't know which is this V means. Someone you can use it this V instead this V. You understand me? Someone you can use this volume, and if you don't study, I don't see before this volume, this velocity, or this what.
Yeah.
Mike, please.
Francis is talking personally.
So the answer, which one, doctor? Number 10?
I will check. I don't know. This velocity, meter per second. I don't remove it from the calculator. Why? Because I know I put it here direct and continue. So I continue calculation here, and I continue in the calculator direct. You understand me? Don't use your calculation in calculator. What's 2K90? What's K90? 1.5. And K45.4. So this one is 10.875 square by 2 times 10 multiply 3.4. Now I can calculate it easily. Continue calculation. This multiply 3.4.
Answer is C.
1.81. Aha, I do something. I don't make a square for this value. I forget square.
Yeah. Answer is 20.51.
I'll check. Just wait. I back the calculation.
I think it's B. Should be B.
975
C.
Close.
square. B and C, according to you make more round or you take the value as it is for
Yeah,
velocity.
answer is coming to 20.51.
I'll check with you.
Yeah.
20.5.
So C.
This what you get it?
Yes.
20.449. This what you get?
Yeah.
Yeah, C.
Yes.
C.
So the answer is
C.
yes, exactly. So as I tell you previous session, sometimes the question coming for minor losses, major losses, both together, part from the total net positive suction head. So the losses is coming a lot in the exam. Okay.
But they given this formula H loss minor like this.
Yes, the problem is like this, because if it's not given, how do you know the number of K90 and so on? It is given as it is.
Okay.
Okay. This is exam problem from the exam, previous exams. Any question?
Sorry, Doctor. Number 5, question number 5.
Number 5, just a minute. Negative 460 from height to Rankine. Check today's session. Third slide or fourth slide.
C.
Yes, C. Check Mr. Ravi.
Number 14.
All comparisons he gave, no?
Again?
Yeah, no, I'm telling that the answer C for Fahrenheit scale.
Yes, C, 5C.
In case of Rankine, answer will be A, right, sir?
Just a minute to see the clear. Yes. Again, is this
You
a-
got the answer from Mr. Ravi, Doctor?
No, it's not sent yet. I wait the answer. Once he sent, I will give you the answer direct.
Okay.
Not reply.
Sir, if it is a Rankine cycle, answer will be minus 273, right?
For this radius, 273 yes. But for Fahrenheit, negative 460. Okay.
If this exam it is given in the exam, we can check from PC, right, sir? The units directly we can
No.
put this value and we can.
No. In the calculator, you have Fahrenheit, Celsius, and Kelvin. You can change something. Wait. Yes. If you write it as a Kelvin by Fahrenheit direct, you will obtain negative. Not. Sorry. You will obtain something like this. I think you obtain negative 460 because equivalent between Kelvin and Rankine. Both is equivalent together. Let's see. Just a minute.
And we may find both answers in the exam. The wrong and the correct one.
Yeah, this is Fahrenheit, and we'll put Kelvin here. So on Fahrenheit scale, 0 absolute is negative 460 Fahrenheit. Yes. If you put it
Yes,
in
exactly.
Kelvin, put 0 Kelvin, you will get negative 460 Fahrenheit.
459.4.
At zero,
Okay, for this
Kelvin is the same Rankine. Clear?
0
clear.
Kelvin is not absolute 0, no, sir?
Absolute 0 is 0 Kelvin.
Okay.
Is 0 Rankine. This absolute 0.
Okay. So we can convert from PC itself if some like this units
Yeah,
conversions come.
I opened the calculator here. I will show you.
No, the
You see?
screen did not. Yeah. Okay. So you put
0
0 Kelvin.
minus 460 Fahrenheit.
Sir, you go click in Kelvin area, sir. You click
Minus
Kelvin area.
73 Celsius.
Yeah.
Below here. You see?
Yeah. So can you just click Kelvin, sir? What are the units shown there in Kelvin?
What do you mean?
The arrow down arrow of Kelvin. What are the units there?
I don't understand you.
Drop down.
No, you
In the drop down.
drop down. I'm saying. Kelvin, I'm saying. Kelvin. So only 3 are there.
Yeah, Rankine not here. So some problem for British unit, it's given by Rankine. And you need to continue by Rankine or Fahrenheit. Or given Fahrenheit and you need to continue by Rankine. So the conversion between Fahrenheit and Rankine should be in your mind. For example, it gave you, for example, Fahrenheit is negative 30. This is in exam 4, I think so. Exam question. I bring in the exam 4. Negative 30. So how to continue? Negative 30 or 30 something like this with 460 conversion Rankine to obtain the degree will be used in the calculation is 360. Something like this. I don't remember the numbers, but you need to change it from one to another by the conversion from Fahrenheit to Rankine. So the conversion is important. And this conversion I already gave you today.
Yeah. Yes, from PC. Yeah.
Yes, I will show you. Page, slide 6, temperature scale. Here. Can you see this?
Yes.
Okay. Rankine is equal to Fahrenheit plus 460. This is important conversion. Clear?
Okay.
Okay.
Question number 14.
More question?
Question number 14.
14. Where is 14? 78. The steps almost we solved last session. Just I change small thing. I don't request the last required, just I request the previous one. That's it.
Sorry, Doctor. Number 12. A. The answer A.
Yes.
Okay.
No more question? All is clear?
Yeah, all is clear.
Okay. See you Wednesday.
See
Thank
you.
you so much for all. Good night.
Thank you. Good night. Thank you.
Thank you, sir.